Okay, so now we are going to be looking at volume and surface current densities, and these are going to be important when looking at the sources of magnetic fields. So first we're going to start with the definition of surface current density, or K. So the surface current density is defined as the electric current per unit width. So if we have electric current flowing in this direction, I, then we're looking at the width perpendicular to that flow of current. And if we have the surface current density and we want to find the current going through a particular surface, we just do the integral K dot dl. And we can find the surface current density in terms of surface charge density and velocity of the charges. The surface current density is just going to be sigma, the surface charge density, times v, the velocity of the charges. The next quantity we're going to be looking at is volume current density, or J vector. So the volume current density is defined as the electric current per cross-sectional area. So if we have current going through, flowing this way, here's that dA when we say dI over dA. To find current, if we have the volume current density, we just have to do the integral J dot dA. And the surface current density, that should be volume current density. The volume current density in terms of volume charge density and the velocity of the charges is just J is equal to rho, the volume charge density times V, velocity of charges. Now we're going to look at what's called the continuity equation. The continuity equation states that the divergence of the current density is equal to the negative rate of change of the charge density. So on this side of the equation, we have the divergence of the current density, and that's equal to minus the rate of change of the charge density. So this continuity equation is a result of conservation of charge. Any charge density that flows out of the surface comes at the expense of that remaining inside. So if anything flows out, we're losing charge on the inside. That's basically what this equation is saying. So you have an example problem to do, and then we will be looking at a few clicker questions in class together. And that's it for these lecture slides.